in a different type of format than having a panel discussion between SQL and NoSQL, because there's been plenty of discussions this week about it. I thought I would do something a little bit different. It's a Sunday afternoon, and I turn it into a debate. So what we have is we have our panel experts that we have today, and so I've determined the blue team, the SQL team over here. We have Brian, Brian, JD, Selena, and Monty. So with relevant expertise in certain types of technologies, most of which you've probably heard about today. And over here in the red team, which doesn't look very good on red on the screen, trust me, it's really red. We're much short, but we have Mike, and Eric. So I know at least one Mike talked yesterday, and Mike talked this morning about CouchDB as well. And Eric from the Cassandra talked to us yesterday as well about Cassandra. So everyone hopefully has had an opportunity to hear them speak and hear about their wares. So what's really important is this is a debate. So it's red versus blue, all right? So we just set the rules of engagement so there's no bloodshed. The blue team will define as SQL rules. If you want to support rules. Nobody's head's going to pop up. Nice. If you want to support them, then you know SQL rules is the slogan we want to use. For the red team, and whilst I'm standing on the red team, I'm trying to be impartial because I want to be in the middle of the screen.
You're wearing blue, so it's good.
Yeah, okay. And the red team motto is SQL is dead. Okay, so keep these things in mind as we go through the discussion. Yeah, that's It's Sunday afternoon.
It's a haiku.
Okay, you know, maybe we should just start drinking Monty's Black Vodka first, and we'll be more easier. So there's some rules of engagement I'd like to set. Unfortunately, I didn't have a chance to talk to all the panelists, so some of these are getting this raw. Good for them. But rather than having a very open-ended discussion, I thought what we would do is we turn it more into a debate. So the opening team will have an opportunity to speak for 2 minutes, and I have a timer so that we can make sure we can cut people off. The responding team will have an opportunity to rebut that conversation or give feedback, and then the first team will actually have a 1-minute rebuttal. So we have about 5 minutes per question. And when the timer ends, I'd appreciate it if you stop talking so that we can move on with things. Bribes are encouragement, and heckling is actually appreciated. So feel free to agree or disagree. You know your slogan for your teams, so feel free to give appreciation. We have plenty of slots for questions from the audience. I know I said it something subtle today. We didn't actually discuss it earlier, but if you want to send me questions, please do. Just send them via Twitter because that's easier. And I guess I'll probably just look at them on the timer so you guys won't see the timer, so that's tough.
You can also send them by Nerf ball if you have one, just pop them in the head.
Yeah, you know, whatever. Although when we get to the questions, and if no one has actually submitted any questions, I might just look for a random audience and we'll just see the randomness and see how that works. So I think that's about it. Do any of the debate team want to renounce their position because now they feel uncomfortable? Anybody?
We'll take a run at it.
What's that?
We'll take a run at it.
Take a run at it. Excellent. So I think without further ado, we can start with question 1. So this is for the NoSQL team that can start. Unfortunately, Brian preempted my questions yesterday, but SQL is a standard that most people actually know and are comfortable with. Databases generally implement it in a consistent manner. That's open source databases, we exclude Oracle. So for NoSQL type solutions, we don't have that standard to work with. So which as developers now are probably comfortable with, and it's a consistent way of working with things. So we want to know what the benefits are of not using SQL in an environment. And sorry, Brian, you can't use your excellent talk from yesterday, so you can bring those points up, but no slides allowed. And also, guys, it's not just one person speaking, so feel free as a team to speak up and use the time and go forth from there. So without further ado, would you like to...
Is this one red?
Yeah, this is red. Sorry, this is NoSQL red. Start. Sorry, the colours didn't work out as well as they should have.
Okay. All right. I'll take a run at it. Somebody that doesn't know SQL that well, you guys should jump in when you want to. So I don't think that we necessarily want to defend that SQL is dead, right? But maybe just not always SQL. I think that my stance would be there are a class of problems that we're seeing more frequently now that require flexible data formats that are always changing and are well served to first order by simple key value pairs with some limited queries on top of that. And so I think that's one example of something that can be built as a part of that, essentially, based on simple CRUD operations fit REST pretty well. And so that's one example where I think a non-SQL offering is perhaps a better impedance match, and has certain, it's a slightly easier problem to solve, and so then you have a horizon for scaling in a slightly different manner. And that appeals to a different set of standards than or a different set of skills maybe every web developer, every SQL-based developer would have, which is just simple, formats, JSON, XML, and simple, REST CRUD operations or something that people do know. And so I think it is possible to treat that as a data storage engine and tap into a wide set of developer skills.
I think one thing to think about here is that somehow this term NoSQL has popped up, and one of the problems with that is that it groups all of these things which are quite different and have different feature sets together. And so part of the question is about, right now there's no standard way to query these things. And yeah, that sucks. And the problem is that SQL doesn't fit the way that you work with a lot of these tools now. And so I think that as time goes on, we'll sort of start to see a little bit of a convergence in terms of feature set. And maybe at that point, we'll be able to see a standard evolve that works well with all of these different solutions.
Yeah, just one last thing in the last 5 seconds. Last week we saw a SQLite wrapper to CouchDB, right? So basic SQL ops on top of that.
SQL rules.
So I guess from the SQL team, you guys can start off easily as like whether you like SQL or not SQL, because the question's a little bit loaded towards the relational database sides. Although I must admit the first comment from, I can't remember whose name it was now, has indicated that they think that Brian is the legal person on the database team. So if you want to stand up and take ownership, you can take a few shots at you, saying that Drizzle is not SQL compliant. So perhaps you can sharp it.
No, there are no relational database systems that are completely SQL standard compliant. So
yeah,
everybody would have to get off the couch, including
and
Oracle.
we are actually, yeah, we're more compliant than our ancestors. So I would actually comment that historically, so like if we go back in time, 10, 15 years ago, there was this database that came out of Berkeley that had, had inherencies and tables, and had all of this, non-very structured systems, that had the ability to look at different, index predicate components based on key pair. And then they made this reality where they said, we're not getting much traction from this. So they turned it from Postgres to PostgreSQL. And so some of what I see right now really is just history completely reinventing itself. Because like the person to the right of me popped on a mailing list, a little decade ago, saying, hi, by the way, I've taken the SQL off this other database and I've added it to my own database, Unireg, which was an analytics database. So something wasn't even like a transactional, typical transactional database. It's closer to an analytics database. And by the way, we added SQL. And all of this occurred because at the time, the whole planet was full of babble and suckage because we had to keep re-implementing our application.
So you may think that you have escaped, but it's coming.
Sorry.
I think that you already agreed earlier that you're looking at interface, and you already agreed that SQL is a proper interface.
Yeah, I think a shining example that I see is something that can leverage a lot of different packages, right? It's the Link project out of Microsoft, right? It's an example of a query language that recognizes SQL first. Certainly you can write, these are relationally complete systems, so it can be done. Right now, that's not the focus. And I don't think it's necessarily to escape, but I think it's been to solve certain problems in kind of the most efficient manner for a specific problem, and then that's starting to be generalized outside of the organizations where they're developed.
Maybe the wrong thing to say during the debate. I want to go sit on that couch, I guess. But I would consider, for the ones that I use, the lack of the query languages as a regression. One that was necessary to re-architect the system that scaled with.
A lot of the complaints really that you can have with database today, if you look at them, are things that should have never been done. For instance, create index has never been in the standard. The reason why is it shouldn't actually need to exist as a concept. It's a hack because we as people who write databases haven't figured out how to write a database where the end user didn't have to kind of give us hints as to what they actually wanted to do. Schema requirements themselves, if you look at it, schema requirements themselves of even having a requirement on a schema, internally in most databases, there's no strong concept internally even of the schema. That's a concept that's expressed outwards for end users to be able to make use of. Unfortunately, there's limited ability among the open source databases to do online table editions and so forth. And that is something. But even the commercial vendors barely have that working, and for every vendor, you have to you have to scrape through the marketing to find out exactly what they're doing out of these points.
By the way, with the Google Lessons database, we didn't have create index. We didn't create an index in the fly. Of course, it was also a huge commercial success that nobody heard about.
Anyway, it's a good discussion. Do you guys would like a rebuttal? I know I gave you some extra time to answer in there, so all right, we might leave that. Is everyone happy that there's no decision on SQL versus as an interface or not? We might leave that question and move on to something more interesting. So, question 2. SQL database products have been around for quite a long time, and they've leveraged the benefit of the LAMP stack and other product technologies to have a lot of open source products that are currently available. Popular ones like WordPress, Drupal, Joomla, MediaWiki, all these sort of things are out there. We now have newer products, some of which we're talking about here, that are used internally. Cassandra, from a Facebook's perspective. Mongo, I'm not too sure what your client base is. One or two good examples for
SourceForge, Discuss, there's a couple other big ones that are using it.
Okay, and then obviously from a CouchDB, you've got BBC, Meebo, and then the Ubuntu.
BBC, Ubuntu, Meebo.
Are big clients. But what I have seen as lacking is that there isn't too many products that the end user can actually use. So what I'd like to know is which industry segments do you think are good for products, or what products are being developed? And obviously from the SQL side, I throw in there, what products do you think won't work in a NoSQL environment? So this is open to the SQL, why did I start the SQL group first? I don't know. The SQL group gets to start first. What do you think doesn't work in the NoSQL, and what won't, how they won't catch up from a product community, a product base that's already out there? So
I'd like to start with my bank account as a transactional system.
You don't need transactions to do it.
Actually, most banking systems are eventually consistent. They're actually not as transactional as you think they are. Most of the banks out there are eventual consistency as far as that's the reason why they won't let you take out so much money, and by the way, when you blow it, they just charge you. So that's themselves are not actually the resolution isn't quite as what we think it would be. I look at so to kind of take the question a little further, to me, for instance, I look at a lot of the no SQL implementations, and what I see is there's a huge failure in the open source database world to build analytic databases. They've just not been built. Good analytic systems have not been designed that are open source. We have had open source technologies turned into good analytics, but that is not the same thing. So right now, what I look at right now, some of the NoSQL stuff, and I say, so you do this, that's analytics. You do that, that's analytics. So I see a need for that sort of analytic databases to exist, and for the lack of them being created in the open source world. I mean, we're only now starting to see Infobrai, Calpine, they're the first two that have actually come out. Lucid, I believe. Yeah, those are the first ones that have actually come out. That's something we've had no work's been done in the last decade in that area.
So do you think there are any types of products that are commonly available as LAMP stack products that, there are a lot of multi-variant versions of blogs and wikis and bulletin boards and bug making systems? Do you think any of those won't work in a NoSQL environment?
I would say any product where you want to embed the language easy as part of the application, and you don't have to write anything. I mean, I hate SQL with passion, and the only reason I used it was because actually, and the select part is decent. The update and everything else is just hell.
Someone want to point that one? So from the NoSQL guys, I mean, we talked about a couple of clients that we have, but what about general products that anyone in the audience here could download and use and apply and install on their server and work with?
Well, I don't know about products, but if I can just start the first 30 seconds with some applications we've seen built off of, I'll talk about Couch, talk about Mongo, Cassandra. I mean, I think real-time analytics is one example. So, you know, Scoopler and Collecta are two of our customers that, you know, wanted to economically build something fast that could consume and aggregate, you know, diverse and various speeds and spit those results back out in milliseconds and analyze fashion. And for that, you know, online incremental mapper uses a nice fit for a specific set of problems. And that's one example, something that's well served by the NoSQL relational store.
Yeah, I think you know, with Mongo, some of the applications that we think are really great fits is, you know, real-time analytics, logging, sessions, that sort of high-volume data. And we are seeing some tool support pop up from the community. You know, it's all open source, and we are seeing some, you know, built-in logging handlers for various languages, or, you know, session management backends and stuff like that. So, you know, as time goes on, I think we'll see more of that.
Yeah, so, sorry, I'm kind of losing my voice. With Cassandra, you know, it's about big data, growth of data that's not necessarily bounded, and distribution to isolate this particular. So you're not bound to a particular geographic location or, you know, shared infrastructure, but you're able to distribute out, geographically. That's a good use case.
And I think one thing that's kind of built into most of these systems from the beginning as a designing principle is replication. So the idea that you're going to have disconnected systems that are going to behave in multi-master behavior eventually. So ground computing is something that's very well suited, I think, to some.
We'll get to that later.
Okay.
We'll tackle that soon. So I don't know whether the SQL guys want to add to the conversation of products we might.
Like I said, there's almost been no work up until recently on the open source databases handling analytics problems, streaming problems, graph problems. Those three have been open fields as far as databases go. I'm talking in general in the open source world, and there has been no real work done on it.
Is there anyone in the audience that wants to add something that they find of value of using, you know, an SQL database product versus a non-SQL product? Not just the ones we're talking about here. There are a lot more. You know, we're talking about LucidDB, MongoDB, other types of products. Anyone want to go? You know, this rules. What is in the world? Use it.
I guess I'm not even sure what the debate's about, because I've never heard a SQL person claim that non-SQL is a bad thing. I've never heard the non-SQL people ever claim that SQL is going to go away. So
we're probably supposed to be a little more offensive.
Nice or something. I need to actually give that example. I mean, what is a database? A database is just a persistent store of data, and we have examples of things that have been around for a long time, like file systems, right? They're a database, and nobody's, you know, suggesting that we use SQL for accessing our file systems. That's not what I've heard.
Not that you can. If you remember.
I started. But you know, so I think the more interesting question is, you know, like, why are file systems worked out the way they are, and why has SQL worked out? I mean, we had one point about why SQL's worked out is because it's the standard way of talking about relationships. And so if you have data that has a lot of relationships, it's great, it's fantastic. I mean, it's the best thing around. And it's never going to go away, but there are large classes of problems like file systems and analytics and stuff or the web. You could think of the web as being a large database where, no, it's not a relationship-based thing. It's a, you know, it's a direction.
So why does organizations like Yahoo, for example, create YQL to make the internet accessible in an SQL interface as opposed to a, you know, a JSON, you know, or document or schema interface? What's that?
Smoking grass.
Yeah, well, I was going to say, build static class libraries for JavaScript. Is there?
So how does height really feel?
Yeah.
Please.
Sorry, I haven't got much sleep. I'm not self-censoring very well.
No, but I guess some of the perspective is that a lot of people in the room here come from a background where you use SQL or have used SQL. How many people here are here that have not used don't use SQL in their job in some respect? Very few. Okay, so.
Okay, there's a lot more developers here than that, guys. Come on.
So the thing is that we're all comfortable with SQL. And quite often, SQL is a standard, and so databases have been forced to use it as access. But it's not necessarily a good thing. And to preclude, before we're going to say at the end, I didn't choose the topic of the discussion, SQL versus NoSQL, so I have some closing comments in regards to that. But yes.
I think there's a difference between SQL as sort of an interface abstraction thing and then the storage behind it. And so SQL is an interface way to think about data.
It's just a specification to access and retrieve the data and manipulate the
And
data.
that's why Yahoo is, in their practice, excitedness, that's why they like it. Because it makes sense, but it's complete, but it doesn't specify what the back end is.
Absolutely, it's using
So
the
there's sort of
specification.
two arguments to be made.
Ask Monty.
I'm going to say this is a little more offensive, so how about...
Oh, no. I should have mentioned that this is a closed environment, no nudity or insanity.
It's all being good.
It's all going to be expected.
So let's throw out that the only reason for non-SQL is because CPUs are not fast enough. If you have unlimited CPUs, you can run SQL on anything.
I disagree. And the reason I disagree is because 10 to 15 years ago, the smart people were the ones putting everything in databases instead of flat files.
Actually, I will disagree with that because the VM operating system and the big operating system, some of the older guys here might remember, those were databases, those were not files, and the files were stored in the database.
Right, but they were in the database. What I'm saying is the better applications and the more scalable ones were ones that use the database, not flat
But
files.
the assumption is that SQL is infinitely fast. Under that assumption, we need NoSQL.
But why was that true 10 to 15 years ago?
But
Not
there's
now?
nothing to be just putting out that the problem is the CPUs, not the interface.
So 10 years ago, the problem wasn't the CPUs?
10 years ago, we didn't have a working MySQL.
It's funny, I thought MySQL was 15 years old, but let's leave that one.
I was using MySQL in production 10 years ago.
Actually, so was I. 1999, I was also using it. So anyway, let's move on. We have a few interesting things, and then we'll get some.
I can be offensive to myself.
So we were almost about to touch on this before, and that's why I was going to cut you off a little bit. And these are my own words. Scalability and high availability in most databases can really suck. I see a lot of bad implementations every single day. It requires you to plan and architect and design your system to support those things. So what I'd really like to know, starting with the SQL group, what are the strengths that you can offer, towards being able to provide environments that give you read scalability, write scalability, database maintenance things, without impacting the user experience? What are the approaches to doing that? Because I'm sure the NoSQL people have a lot of comments on how to solve these problems. Would you like to start? SQL rules. What are the strengths that you have from a relational database perspective to be able to solve those problems of scalability and database maintenance and providing a solution to the users that's always up, that's highly available?
Well, I'll just admit that Postgres has not done great in this regard. We have several add-on tools that you can use to achieve, replication. Right now, a lot more work is being done to have built-in replication with Postgres, and it's something we kind of ignored for a while. So I wouldn't say that the NoSQL folks really spurred us on to do that, but it is just more a competitive reality of needing to scale that way and make it easier on DBAs and setting up those environments. So we're working right now on hot standby, so we have binary replication, and you can read the slaves, because right now with Postgres you can have binary replication, but you can't read the slaves. We're also working on asynchronous replication, 2 big patch sets that hopefully will get committed next year.
I guess from my scope perspective, you have replication, but perhaps JD might want to mention about the synchronous solution of cluster.
Sure. Well, I want to look at it in a bigger picture, actually. So, an SQL database can provide easy upgrades. It can provide easy scalability, or it can't, and that's No, that's really up to individual.
Let's say altering a 600 megabyte table that takes 4 days.
Well, you know, so Monty had the idea early on that a lot of MySQL upgrades would not require you to dump and reload, right? And it was a great idea, and then we started changing data types, and it didn't work anymore. But this is a question that just goes beyond the classifications of how you manage data to how well a particular implementation does it.
Yeah, I mean, there's a lot of, well,
I was going to say that you also highlighted a point though. So NDB, the engine right there, it should be over on that couch, right? Because it's actually not, it's a non-SQL system. The whole thing though is that reality-wise, at least for some of our work for our databases, we nowadays are starting. Personally, when I look at Drizzle, I don't look at storage engines anymore. We look at what we call data management layers. So our data management layers of whoever we talk to, whoever handles data, it's not really a question anymore of, the question of, hey, how fast did I make my disk, or was it in PCC? The bigger question is for most folks is, hey, I've got terabytes, petabyte of data. How do I access that data? How do I get access to that data? So a lot of our work right now, and a lot of what we're getting paid to work on, is to refactor, for instance, our DDL operation interface stuff, so we can actually just pass that stuff down through. So that really, we talk to the back ends as data stores, and that's the interesting part for us, is how do we interact with data stores? Because we are a SQL engine. We are same thing as if you had written a piece of Perl that would sit there and access one of these systems. The database layer is exactly the same thing. The SQL parts of the joint optimizer, it's just another language interface with what is a data store. I mean, NDP proves that. We were sitting around talking about how to make this work with Cassandra. So we can just have Drizzle directly on top of Cassandra. And by the way, it's not that hard, and it works. So it's kind of a...
Anyway, red team, because I don't like NoSQL either, just to say, again, I'm just using the name. So let's look at the red team, that sounds better. Ferrari red. Do you want to give some details on what you consider as great strengths to be able to solve some of these classic problems that people seem to have?
First of all, I'd like to say, and I hope I can make it out of here alive afterwards, that the NoSQL name was actually something I came up with. By accident. Only because I happened to be sitting on an IRC channel when the guy who arranged the first meetup said, hey, what should I call this? And it was like one of 3 or 4 things I threw out. I wish I hadn't.
We had to mutual.
Yeah, because suddenly it started this anti-RDBMS thing. None of us had any intention to do. But yeah, this is, all the 2 questions before this are all, and again, I assume, it seems these discussions always blur the distinction between the query language and what we're all used to having that sit on top of. But more and more, data is getting bigger and bigger, and especially when you're over backspace, so we have a lot of shared systems. And if you ask a question about how far out they need to scale, the answer is always yes, without bounds. So, traditionally,
and seamlessly, without doing anything.
Right.
Turn it on, it should just work.
Right. And failures are going to happen. They're going to happen a lot. There's nothing you can do about that. Entire data centers can fail, and so you have to be resilient to that sort of thing. And the traditional relational database, sharding and clustering schemes, it just, I don't think I need to tell everybody that they all have significant drawbacks. It's something I'm sure 10, 15 years ago no one was even trying to do. It's been bolted on since, and I think it kind of shows.
Yeah, a lot of these systems, what you're giving up is the ability to do joins, because distributed joins are really hard, and the ability to do complex transactions, because those are really hard to do across horizontal shards as well. So the question of how can you do this without without impacting the user experience, I don't think you need to impact user experience all that much. So I think that those are the 2 main things that all these systems need to give up if the goal is to scale out horizontally. And I think that there's a lot that they don't need to give up in order to do that. So that's certainly what we're trying to do, is sort of bridge the gap here, like not throw away everything that people are used to doing or the ways that you're used to working with a database. But
part of the main thing here is sharding. Sharding can be done in an 80-20 rule, where 80 is very easy to solve, and the 20 is really fucking hard, and it's not a simple case. Read replication scale out is a dead idea. Read replication scale out is eventual consistency. It never reads because it's never eventually consistent. It is eventual, but it's never consistent, because if you have 20 nodes, 100 nodes, 200 nodes, anybody who's ever programmed against a read replication environment knows every node has potential to be different. So providing any kind of user experience across that is an absolute disaster. This is why we see things like CouchDB being placed in front of it, because read replication is what? If you've got 20 boxes, if you have one master and 20 slaves, the number of end writes just increased by 20. And slight little discrepancies in boxes, they're never the same. This is the reason why CouchDB has been brought in.
I think actually the next question touches a little bit more on the eventual consistency that you're talking about, and I was actually right. So you were talking about a few things. One thing that's been mentioned today is about transactions, or the lack of transactions. And so there historically has been known that we must use transactions in essential systems. And particularly if you come from like an Oracle background, MySQL is a toy because it didn't have transactions, which is actually not an accurate statement. But from my perspective, I want to know how my bank balance will work in an eventually consistent environment. And the systems that can survive without the consistency, whether it is a transactional consistency or a database-centric consistency of the database being consistent with the view you're looking at. As Brian said, they're consistent only at the point in time in which they are. Eventually consistent is actually not possible unless the system is effectively dead. They can be eventually consistent, but an online system isn't be. So, the concept of consistency, fault tolerance, transactions, these are all things that I think from the NoSQL group, you have a greater education that you need to educate the more traditional developers. And I want to know what you think is the best way to approach that kind of lesson experience so that they can leverage your products in the strengths that you have.
Good question. Kind of a hard one. I don't know. I'll take a stab at it.
Debates aren't supposed to be simple, I think.
Yeah. I think a lot of the NoSQL products that you see popping up definitely start. Typically the third slide on the presentation is the CAC theorem or something like that. But all around the idea that you want to build a storage and query engine that allows you to run in different kind of parts of that base space, right? Depending on what the application need is. And of course, that depends on whether you're interacting with a single cluster, right, or multiple clusters, in which, okay, conflict resolution, when you have geographically separated writers, is extremely hard, right? It's something that, at least within the Couch community, we're actively debating what the right interface is there and how you present that back to the end user. But to first order, I think what you have to do is build a system that has proper, at least MDCC snapshots for all transactions. You have to propagate conflicts or conflicting, data values through the system, and then you have to figure out what is the optimal way to tell the end client that there was a conflict and allow them to resolve that. Some conflicts are easy to resolve on the server side. Same rights going into the same document at the same time, right? Revision control solves some of those easier ones. But when you have multiple producers being funneled into a new cluster, that's a very challenging one. And I think within Couch, that's an open debate right now what the API should be. But at least we're passing around and replicating the conflicted documents and exposing the ability to upload server side your own conflict resolution logic. But it's education is a challenge.
Yeah. Maybe on the front of education, a lot of people hear eventual consistency and they think, oh, so it's inconsistent. Well, the CAP theorem is relevant here because the CAP theorem says that at any given moment in time, you can only have one of consistency, availability, or partition tolerance. So it's only really going to be inconsistent if you had a machine failure or a network partition. I mean, the expectation is that it's consistent. And the read repair and so on in order to roll up those values later on. But is eventual consistency a good idea in financial systems? Brian already mentioned that they're already eventually consistent, and I would rather have availability. I mean, if someone's going to deposit something in my account, I'd rather have make sure the system actually.
Yeah, I really agree with my concept of if there's a conflict, then the user gets to make a decision. Well, I'm always going to want more money in my bank account rather than less. So someone's going to get unhappy.
eventually consistent. When you go in and you say, I want this much money, the machine doesn't always actually know exactly how much money you've got at that given moment. It does know, has a rule system that you're allowed to max take this much out. And based on that, it gives you that much money based on what that rule is.
Yeah, but that rule's about banks being greedy. It's like, if you don't know how much money you got, we're just going to charge you a fee because we want to make more money.
Yeah, it's bad.
So,
It's actually a lot more complicated than that, because you can actually only authorize a certain amount every day, but.
So the whole thing is that even if we look at, like, for instance, take a database like HP Nonstop that's used in these environments. HP Nonstop actually does do eventual consistency, but it does by checking, by looking at generation IDs. It's actually a funny feature we actually have in memcached as well that allows you to determine that the action that you're doing, no matter when it's propagated, is being done against the original item of the actual action. And that's something which is beyond atomicy that we actually see in databases for the most part. Nonstop's one of the few I can think of that actually have it. But, you know, that type of changes that you see saying, yes, this will eventually consist, but when it does, we want to know that it happened in exactly the right ID from the right time. So it's not that this stuff doesn't actually exist in the database world, but once again, it just doesn't exist in the open source database world. And I think that you will find that when you try to do this, you're going to end up finding similar things that have been found.
Yeah, and I think if you look at how these things are implemented, I think we use like standard technology. I mean, I think one of the differences with respect to some of the things 10, 15 years ago is we're not throwing those away, using B trees and connected blocks and standard technology.
Please don't stop on my car. Yeah, go ahead. You know, I mean, surely someone has an appreciation about transactions.
Well, I think you guys are getting a little too focused on banks. Well, one use case where, and you make the point that it's, what we're seeing right now is that a lot of the NoSQL stuff is getting a lot of PR because these guys' marketing teams are doing their job, right? So now we've got developers who rely on us to tell them yes or no to their data needs, coming to us saying, oh, can we use this? So it's really up to us to educate ourselves on what the right use cases are for both, so that then we can go to our clients, to our developers, saying, okay, yes, this looks like it'd be a great idea to use MongoDB, for this. We can get this out of the database, that'll actually speed up the other stuff that needs those transactions, because we're offloading this. So to me, that feels more like a better way to phrase the question is, okay, when do we need transactions, and how do we communicate that effectively to our clients? And when is it okay to say, okay, cool, we can just start, slamming mass amounts of data into this column store?
That's a good question. In fact, I have a follow-up slide that's a question that's very similar to that. Anyone else want to add some comments on why transactions won't work in real world?
I was just going to say something about pullback.
Okay.
Think about you write a check. When you write the number on there, it doesn't mean it's immediately subtracted or added to whatever account is going to, nor did they clear your check right away. It's kind of asynchronous if you think about it, and eventually consistent. Or when you go to your deposit box at night and stick that thing in there, nobody's going to act on it until the morning.
It's unfortunately eventually consistent.
And then there's other things that are extremely important here that are fail-safe, like airplanes. You don't want them to fail. You want their data to be always real.
Yeah, you want it to be real time.
Yeah.
But actually, I want to be consistent real time.
On the other hand, Web 2.0 content radical business, because you need all those Google toys to get the ads done and show them not a done this transaction. Or the Facebook or the Twitter or whatever.
Sure. I think most systems are now the Web 2.0, which is, I think, unfortunately, of all the people in the room, who actually works on something which is not effectively Web 2.0? Who works on a banking system or a military system or someone from NASA here? So obviously they're not like using rockets by collecting data or gaming, for example. Most of the things we're working on nowadays are really user-centric. Toys, I think, is a half word maybe to use, but what business applications that affect your day-to-day life, like banking. Who here doesn't work in an environment which is sort of, caught up in this Web 2.0 world? Most of us are. Most of us impact that. So there's a couple. What you want to share a little bit?
Well, I think any company that bills per anything, you can't screw that up. I mean, if you're off by more than about 0.1%, you're going to be screwed up. So if you're in advertising, you have to be, you know, pretty much accurate down to page views. And that seems like something you could track. Oh yeah, you know, page view here, page view there. But if you're doing a lot of, not analytics for just reporting's sake, but if you're using that feedback into the actual user behavior, not only can you build incorrectly, but what you choose to optimize on, story A or story B, you know, it could make a huge difference.
Right, or you decide to use, like, say, floating precision for something that you're going to be doing.
Yeah.
You know, that's something that's happening no matter what. But that's also, transactional is, so something that's transactional, if you're taking it to be ASCII compliant, that is a way not to lose data. And I think we're conflating, if you're not transactional, you're going to lose data. And so we're using this term like eventually consistent. I mean, we're just not like real-time transactional. It's not like, you know, this happens and if it doesn't happen, it's going to roll back immediately. Like, does it really matter if, you know, I deposit something into my bank account and it's an out-of-state check and, you know, my bank apparently can't call another bank and say, is the money there? Like, it doesn't happen right away. But that doesn't mean that I lose data. So I think that it's kind of a weird definition of transactionality when you're saying that. I think they are transactional because they're not losing data. But
what I usually think the way of it is what is the durability level of the actual data? Because what users care about is was my data durable? When I inserted the data, from that point on that I got a request back, now it will eventually be seen, but was it durable? And what's the level of durability? Was it durable to this data center, to this machine, to this, you know, set of geographic nodes? Well, what is the level of durability I can expect of my data? And I think that's really what matters. It's not that they want to hear, you know, what the command they don't want to hear is commit. The command they want to hear is sync. They actually want to know, was it synced? Once they know it's synced, that's when everything's good. Whether it's viewable at that moment, who necessarily cares?
isolation is dead. Atomicity is important, but if you're in the middle of a transaction and you're seeing stuff, right, because let's say money has been authorized to be debited from your account but hasn't been debited yet, or whatever non-bank you want to use. So the isolation has completely gone away, but you're still having an atomic transaction, right? I never go to the bank and take out money and get my $500 from the bank, and then the bank forgot to actually deduct it from it's still an atomic transaction. It just might take a while for it to actually, again, be eventually consistent. The durability is important. I think the atomicity is important too, because you need to make sure that, again, if I don't get my money, then it's not debited from my account, and that does happen. It's just not. It's not within this isolation level of nobody else is going to see that, right? So sometimes I look at my bank account and I have like the amount up here that I have for, you know, withdrawal is a lot different from the balance over here because there have been some authorizations that haven't come through yet.
I think the key thing to consider is that with a traditional transactional database, at the point you're making a decision which you cannot roll back, you are using consistent data. Whereas in an eventually consistent thing, you can't really make a non-rollbackable decision unless you knew that your data is consistent at that point in time.
Say this again, because I don't think you're...
well, at the time you make a decision, which is real-world impacting,
right.
If your data is only eventually consistent, but not consistent at the point of time that you made the decision, dependent on that data, then you can have a problem.
But what you're talking about is the difference between the data actually being visibly collectible and whether or not the data actually had the ability to be durable. Think about we have one storage engine inside of MySQL and Drizzle that is what? It is actually an eventually consistent engine. It is transactional. You can insert data into it, you can roll back data into that engine. But the data is actually only visible once the data has been replicated to another machine. Black hole engine. The whole reason for its existence is as an eventual consistency model. Deutsche Telekom wanted to do very fast insert rates and was happy reading data based off replication. But they did want to know that it was actually committed data. So you can't have eventual consistency in an actual rollback transactional model that just is viewability as the eventual consistency.
You just described the couch storage engine, right? Every interaction is an ECC snapshot.
I mean, but
the question is whether the queries are up to date.
That's just scaling out from the way NoDB or something works out. I mean, that's taking the same model that is on the internals of NoDB. You know, if you start a transaction with NoDB and you start doing stuff, it's writing data, it's doing stuff, but that data is not visible until the end when it says, okay, we're all done.
Well, the data though is visible to the user who's doing the interaction during that period though.
Not everyone.
Right.
Yeah, but not everyone else.
Right.
Well, hold on, what you do in the isolation.
Right. Well, I mean, but then I was going to say an example towards another example as far as what you were saying, you know, when it's visible is what matters in a way, because say Amazon pushes a price change. You know, they don't want that price change to be visible until it's going to be visible from all of their servers. Otherwise, they're going to be getting really confused when one purchase hits at the old price and the other one hits the new price, and then all of a sudden their books aren't bounced.
Yeah, by the way, my understanding of the way that it works actually is that it can happen.
Oh.
It's not a, you know, the thing that, like, you talk about banks being consistent, you know, how do banks count mass coins? If you think they have rolling machines that sit there and check every coin, most banks count coin by weighing them. They put them in bags and they weigh them. There is discrepancy as to how much coin there is, how much money is in those bags, but the cost of actually determining the real value of that, not worth it. It's just okay to actually fudge it in the systems.
Right, does it really matter if somebody ordered it at the time that it was more expensive, but versus if they ordered it 5 seconds earlier and it wasn't more expensive? Like,
So,
does it matter?
let me just add one.
Stock market that matters.
Well, yeah, good point. So. But let me just add one thing
Do
to
you
what.
work the stock market?
Let me just add one thing to what Sherry said, which is something that I educate clients with. And it was actually comes from an interview question that I had many years ago, where someone thought they would stump me with a hard question, and they said, well, you know, we use the dig site. How do they make sure that the counters are always the same on the dig site? There must be so much traffic. How do you know which one's up and down, which one's right? And I said, well, you make an assumption that you're looking at one consistent database-centric view. So it's database-centric consistency. What you're actually seeing is user-centric consistency. The view in which you're looking at is consistent with what you expect. A little bit like some of the other things we're talking about. So, you know, in an eventually consistent environment, as long as your view is right and you vote for something and it goes up, you're going to be happy. Unless you're looking at a screen right beside you at the same point in time and hitting up arrow, and you can never guarantee they're going to be the same anyway. So you're concentric, as long as your user-centric consistency is maintained, then you are happy as a user. So eventually consistent, you know, is irrelevant from your perspective. And quite often, sometimes developers think of the entire database always has to be consistent. And that's actually not the right view to look at things, unless you're working on something which is mission critical. That's my take on it. And everyone's now stumped because I have no idea what I'm talking about. I do. Anyway, because I know we want to do some hacking, and I've got 2 other things which we sort of touched on. So let me bring those up, and we can have more of an open discussion, because everyone's getting bored, I can tell. You know, no one's thrown anything, no one's Yahoo'd or anything like that. We've segregated these people. We've segregated these people between SQL and Eric's very poor term of NoSQL. But you know, why can't they coexist? There was a mention, I don't know who it was, I think it might have been MongoDB yesterday, where you said people use MongoDB as a caching tier. You know, are there any environments where you see that you guys can work together between metadata or caching? Is data interchangeable? What's the benefits or disadvantages of working together, you know, happily?
I think there's a lot of cases where they can be used together. For example, the site Discus had all of the data, I think, in MySQL, and so they're developing some new portion of the site that now is using MongoDB. So it's not like you have to, you know, say, okay, we're going to migrate everything over, and now we're using this. And I think what we're going to see is sort of more of no longer sort of a one-size-fits-all solution. And there's nothing to prevent people from using more than one of these tools, where one tool fits one portion of the job and one tool fits another.
Monty, you want something there?
I think that's the most beautiful place where they can exist together is a storage engine inside of MySQL.
Shouldn't you say storage engine inside of MariaDB? I mean, not too much on there.
It's the same thing, just the new version.
Okay, so as long as you go to an SQL interface, you're happy, is that what you're saying? Alright. Patrick?
I developed the memcache functions for MySQL, so it allows you to take any mem-capable store, and you can use MySQL as kind of the catalog or the brains of how things are organized on the key value store. So that's one way you can do it.
You're just leveraging the language,
and NoSQL.
the syntax.
Yeah, you're basically using the database as kind of a way of knowing where everything is and what is cached and what is not cached.
You mentioned JD, you know, shouldn't be in that couch, but actually.
I didn't say anything about any couches.
Well, you did, somebody did. But actually,
blame CouchDB. I mean, is that couch? Who's invented the chair DB? You know.
But it's the same thing. You know, as clustered, you know, you have the non-SQL or you have the SQL interface. Sphinx is another one.
That's right, the next time you do this, the four of them should be sitting on a table.
Sitting?
That's a really common architecture already, like everybody here knows that, right?
Just dump all your data in one table.
No, not the table thing, just going back to this question of working together.
But actually, with Sphinx, when I did look at it, one of the reasons I selected it is because it had
an SQL interface. So you're falling back to using that specification because you're lazy?
No, because the developers, they thought they were lazy.
Right. Are they lazy or they're just not educated in how to use?
They're lazy to get educated.
Lazy to get educated.
Well, plus if all your data is already in an SQL database, it might be easier to, you know, in the migration process, whatever, to use the best of both worlds and to, you know, like things like Memcache where you can populate one by using the other.
What do people think about that? Do they think that it's...
Well, I think switching like from full text index on MySQL with my ISAM to Sphinx and using the MySQL interface, much easier move than going
to the scene or something like that. Yeah.
Or the whole Sphinx, but use the non-SQL interface. That's why it works.
Or the storage engine.
Anyway, so let's go one more, and then I have some closing comments, and I'm sure we can have further discussions. And we do have some further hack time, and I think we have to be gone by. We have the books, and we have to be out by 5 o'clock promptly. So we'll keep moving. So one thing that's important, because we are the open source community of various products, and the one great thing about this event is it's not one technology or group of people we're talking about, it's a whole multitude. And having seen many of these iterate, particularly from the first MySQLCamp, we moved into something where there is more discussions about things on that board which are not relational databases than there are, and I think that's great. But one thing that's interesting about that is that I've determined from something else, you can have great code, but if you don't have a great community, then your product is effectively dead. So, you know, just some comments on what people think about what are the best things they have in their individual communities, what they think they could do better, what they could steal from other communities. In terms of guides, I mean, I'm very proactive in Drizzle, and there's plenty of things about why I like the Drizzle community. Perhaps, Brian, you might want to mention some of those things that stand out and see if we can get others to stand up.
So things that we've done, things that I've been really pleased with that have happened in the Drizzle community. One, we've gained a very large development engineering group working on Drizzle. A lot of that's based on contributing basically taking all contributions and treating them as, you know, based on their value and merit, not based on who they work for or where they came from. And we accept all contributions from the standpoint of, like, small bug fixes are just as valuable as, you know, large feature pieces. You know, other things is we try to keep the community at a very kind of peaceful, you know, try to negotiate with individuals, work with people, basically keep assholes off the mailing lists and actually keep people to, you know, actually communicating with one another. And that's actually been that's been one of the most wonderful things about actually working within the community. And just really just trying to accept all ideas and explore ideas and encourage people to explore ideas.
Guys, in the couch side of things, how do your communities get growing, and what works, what doesn't work?
Yeah, I mean, from the CouchDB standpoint, I think one of the key things is becoming a top-level Apache project, right?
Yep.
That certainly keeps it open and transparent from the beginning. By design, one of the issues we're dealing with now is how do we gently integrate companies like my own that are commercially developing that project to make sure that everything is going back into the open source.
So about February this year, I think, is that right?
With the top level?
Yeah, top level.
I actually don't know the date. I think it was earlier than that, potentially, but.
So that's a big thing.
Yeah, that's that is at the core of this project, along with a relaxed theme, to try to keep people working together and essentially chill.
Here's a good thing for Selena. I mean, Postgres has been around a lot longer than MySQL. Why isn't it the most popular database?
It's been working a lot longer than Postgres. How's that?
No, I mean, there's been a resurgence of the community.
A little bit.
Yes, a little bit. And part of that
and very
comes.
graphical.
And I would say that there's a focus on correctness and code that conforms to a very rigorous standard and almost like thesis level defense of your code when you know, almost kind of like a hazing ritual that you have to go through to submit it. And you know, there are a lot of us that are trying to change those attitudes by bringing newer developers in, having some of the newer committers speak up about new patches that come in more quickly, and also having a very wide-ranging review process. So we created this thing called Commit Fest. So every 2 months we invite people to come in and review patches. We created like a very detailed, here's how you can review a patch, even if you don't think that you know C, or you don't think you're good enough to submit patches or review code for Postgres. Here's how you can help. And that's actually really increased our reviewer population. We still have a problem with having people who know the core code base well enough to review like the really big important patches, but we're starting to kind of train people up to kind of expand that base. But as far as like why Postgres did not expand initially, I think there are a lot of things that played into that. One of them was I think that a lot of the Postgres developers kind of thought that the web was a fad. And you know, I mean, they just really they kind of lost out on serving developers, you know, serving them user interfaces and programming interfaces that really help them be very rapidly productive. And I think that attitude has changed quite a bit, and you can see that just in the number of new contributors that we get every month, the discussions that we have in meetings that are quite a bit different, and just the responsiveness to requests for help. I think it's changed a lot in the Postgres community over the last couple of years.
Anyway, in the best interest of wrapping up, I just wanted to have a few closing comments. First of all, I think SQL and NoSQL are actually very poor descriptions. Quite frankly, you know, there's a term that's going around now called OldDB. I don't necessarily know if I agree with that either, you know, in terms of relational database, non-relational. You know, does OldDB stand for key value stores or schema-free? I don't know if there is a better description. I do know that after today, I'm certainly going to be using the hashtag blame Eric rather than blame Drew's cancer to sort of make reference to the fact that I think NoSQL does a disservice to both sides. And I don't think anyone here in the audience would disagree, I hope.
I would.
Yeah, well, John, go lie under the table and drink some back vodka or something. I think that'll make you feel better.
If it's going to be able to be changed, it has to be done soon.
I think it's too late. I think like everything that the name is stuck and it's a poor name. I don't think that. Well, the good thing is that what is a better description? Maybe that should be the debate question.
Well,
you know, if we don't like it, what should it be?
Is that pretty soon a bunch of companies will start calling things that aren't NoSQL. The name will have no meaning. Same thing that happened to cloud and everything.
Yeah, I mean, look at the 64 different descriptions for cloud computing, so I rest my case. But I do think that NoSQL, these guys that are sitting in the NoSQL side, it does a disservice to everyone. I think that there needs to be a better that we work more together, and that was one of the questions. And I just, you know, part of some of the discussions this weekend, including something I'm going to show in a minute, is that there are blended solutions out there. CalPoint is a good example that uses an SQL interface to a column store, but also has non-SQL tools to access its data, like its data, for example. So, you know, why is there one versus the other? I didn't sit in the discussion this morning, but I heard afterwards, but you know, MongoDB is actually a JSON interface into NDB cluster, and most people would assume that NDB cluster is a SQL database, but natively it's not. It actually has a C API and it has an SQL interface on top of it. And it's, you know, we're talking about eventually consistent. Well, cluster is one of the products we talk about that is always consistent. So, well, always consistent if it's up, I guess, being a synchronous nature rather than an asynchronous nature. My experience with the cluster have never been good, back to like 5.1 days. And you know, and also from the Drizzle perspective, Brian touched on it a little bit. I mean, the approach of Drizzle becoming basically the glue, the communication between various things. Integration to GIM, and now which does distributed computing, which would allow you to do MapReduce functionalities. Integrating to Memcache either natively or by UDF functions. So all of these things are starting to blend together, and I think as developers, we have to realize that we should choose the best product for the best needs. And sometimes the hardest thing is realizing, A, what the needs are from the users. I know I have clients that are so demanding that want large systems, they've developed it in isolation. They go, we need this. We go, well, you can't have that because we don't support it. Or something like, or they're pushing the technology into a certain product. They're trying to use full text where, you know, a huge MySQL database is not designed to do that. Use a product that's good for full text. Or use medication and so forth. So I think as developers we need to keep our minds open for what's best, and I think, you know, OpenSQLCamp is a good name. Whether we have to remove the word SQL in the future and make it put something else. Well, then database is limiting. Is medication a database or a key value store?
Table cases debate whether a digital operating system should be paged and treated.
Our database operating systems and our operating systems.
I agree, and a talk that I gave some time ago, and I gave earlier this year at GoDaddy, one of the tech days, was the data landscape. And when people talk about, you know, is a relational database dead? Well, no. I mean, it's just a product in the suite of what I call the data store. So I think if we use the concept of a data store and we start, you know, abolishing that terminology, it's the way in which you can store and retrieve data based on your requirements. And whether it's stored in a relational database, a non-relational database, persistent, non-persistent, memory, disk, tape, or printed on a piece of paper, or whatever. You know, what's important is that what the requirements are. You know, the persistence requirements, the SLAs in terms of distribution of how much, how frequently, are the things we have to focus on. And I think that's basically all I had. So thanks for the panelists for standing up. I don't think anyone actually won. I don't think anyone actually lost. That wasn't really the purpose of the discussion. It was more a matter of just opening our eyes to what's going on. So thank you. Thanks very much.